Hello, we are Team 3, the Shard. Last week, we talked about core. Core constructed above the plunge column because of top-down construction. And core construction method was slipform. It is faster than conventional formwork. So, constructors could reduce construction period. Today, we will talk about structural characteristic of the shard. The shard has an unusual characteristic. The building structure is hybrid superstructure. As the number of floors in a building increases, the materials that make up the floors changes twice. But hybrid superstructure is very hard for structural analysis and construction. This is finite element 3D model of the shard. It is very complicated to analyze structure and construct real building. Then, why did the structure of the shard have to be hybrid? Because the shard is designed as complex building, each floor had to be constructed as an optimized space for each usage. In detail, let me explain office floor first. There will be various arrangements for each company's purpose, so variable and large open space is better on the office floor than fixed space. So, office is located at the lowest and largest part of the shard. And to make large open space, designers had to reduce the obstacle like columns. This is a structure of composite beam floor. There are very few columns inside the area, so large open space could be made. And I'll explain the shape of the beam which made space without columns. To make long span beam, composite beam and slab was best choice. So, steel concrete composite beam was used. The web is very long, 500 mm, so second moment of inertia is big. And the beam is composite beam. In the compression area, concrete takes stress together, so compression strengths become bigger. Therefore, 50-meter long beam without columns could be made. And office needs air conditioning, ducts, piping, cables. Circular holes of beam made it possible to make the ceiling very thin, so the height of each floor could be reduced. Next, hotel and apartment. Hotel and apartment part used post-tensioned concrete. There are many reasons that middle part of the shard used concrete. First, because of 911, skyscrapers are required to improve fire resistance, and most of skyscrapers didn't use the steel structure. And for the profitability of the hotel and apartment, designers had to put many floors in the limited height, which they wanted to reduce the thickness of each floor slab. By use of post-tensioned concrete slab, the downstand beam could be removed, so thickness of slab was reduced. Conclusionally, By using post-tensioned slab, extra 2 floors could be added. This is section view of concrete floors. Compared to composite beam floor, post-tensioned concrete floor reduced floor height 550 mm. Also, concrete slab is thicker, so the sound insulation performance, which is very important to apartment, is better. And as we talked previously, concrete part provided damping to minimize lateral acceleration and thus reduces the swing of the building by wind. Next, spire. High-rise part of the shard was not good environment for apartment because of small area. So, the designers made the spire as observatory and radiator. As radiator, it acts as a heat rejection for the building. We'll talk about radiator when building efficiency presentation. There are floor plates every third level of the spire, and central mast provides stability. There was a big problem in spire construction. The area of construction site was too small and too high, so to construct steel frame at the site was impossible. So engineers decided to make module in the ground and raise it up by crane. Construction of the spire was very challenging and hard process. We'll talk about it at construction presentation. There were many problems to construct spire. At this high height, lateral load such as wind load must be considered, because wind pressure getting stronger as height goes up. Actually, in strength wind, the shard is intended to move up to 50 cm. The shape of the shard is good in terms of wind pressure strength. The higher the building goes up, the side area of the building becomes smaller, and force is multiplication of pressure and area. So, lateral load isn't getting much bigger. And to take lateral load, engineers designed head truss in level 66 to 67. Head truss distributes lateral load applied to core to perimeter columns, so reinforces lateral strength of the building. It is like ski pole. When you are skiing, something pushes you lateral. Your arm is head truss and perimeter column is ski pole. Finally, I will talk about method to connect different materials. To match the plan to use, post-tensioned concrete should start at level 34, but in rear, concrete starts at level 41. This is because of perimeter column span of concrete floor and steel floor are different. To make concrete slab without downstand beam, the limit of perimeter column span was 3 meters. Engineers found the solution to connect these two different columns. As solution, in level 37 to 40, top of the steel levels, blended truss changes the span of perimeter column from 6 meter to 3 meter. And the area of the floors becomes small as the building goes up. It appears to have a smooth taper form, but look closely, it is not. The slant perimeter column transferred to vertical column by a load sharing system. There are even column setback exist. The inclined perimeter columns step back toward the core because of a limit of ground level. Therefore, changes of direction generate substantial horizontal push and pull forces. These forces are taken back to the core by diagonal steel floor framing. This time, we talked about structural characteristics of the shard. Next week, we will introduce about construction method of the shard. Thank you. We are Team 3.